Alright, there is no 0 because it popped, so if we read the directions on the bottom of page 2, it says determine the concentration percentage of the egg. This would be, it says corn syrup, I use sugar instead. The sugar concentration in which the mass of the egg does not change. To find this, draw the straight line on graph 2.1 that best fits your data. The point at which this line crosses the x-axis represents the concentration of corn syrup that is equal to the concentration of sugar within the egg. At this concentration, there's no net gain or loss of water from the tissue or the egg. Indicate the concentration of sucrose, that's the same as the sugar, in the space provided. So what did we say our highest percent increase in the mass of the egg was? 9, and then the most negative number was? Negative 8. So I think there's enough squares on here for that. We don't have to be creative about how we number this. For this case, each line would be 1%. So I know I'm going to have difficulty numbering this because I'm on a very small screen and with a stylus. But on your paper, you can number up 0 up to 10 probably, and then the negative down to negative 10. So make sure your numbers are by your lines. Okay, the next thing we got to do is number the x-axis, and we are going to number that down at the bottom, not up here where that line is. That line is 0, but we're going to number it down here. So we've got our percent values ranging from, what's the smallest percent we had? No, percent. I'm sorry, percent concentration of the sugar water that we use in our beakers. 0, and what was the highest? 60. So I don't know how many deals you have here. We can probably say, no. Hold on. Let's know if you watch. So this first line will be 0. Oh, that's not my pointer. Okay, so the first, right at the edge there would be 0. I skip a line, I go 10. Skip a line, 20. Skip a line, 30, and so on. I know we only went to 60. We probably could have spaced that out better, but that's all right. And what was the change in the mass, the percent change in mass for 0?
Unknown.
Oh yeah, it was unknown. We can't do it. Okay, so let's move on to the next one. What was the next beaker? 10%. And what was the change in mass for that? 9. So we're gonna have a point plotted at 10% for the x-axis and 9, positive 9, for the y-axis. So somewhere around there. It's just a point that's plotted. Trying to erase that. Hopefully when you plot all of them, you have something similar to this. Okay? So in the directions it says we're going to use a line that fits best through our data. So we're going to use something called the best fit line. For a best fit line, we get a straight edge, so we can pass out rulers. And you're going to hold that ruler over your points or next to it so that most of the points fall in there. And then you're going to connect them. So I'll show you up here what mine might look like if I were to try to get a lot of my... Okay, so I'm going to get a straight edge and try to lay it on as many points as I can kind of get and put a... I got something on. Can't draw with that. so mine's not straight. Something like that. Okay. You guys are going to wait to do that or what? Oh, they're right here.
Yeah, they're right there.
Sorry. Good ruler. I just use a piece of paper, but whatever. If you have something straight, does not have to be a ruler. Something straight.
Darn. Boom.
What I'm looking for here is the point where my line crosses that solid black line in the middle, where 0 is. Let me get a different color here. I'll circle it on mine. So I'm looking at this point right here, and I'm going to go down on my graph where that meets in my axis on the bottom, and whatever number that crosses with, so if you get a straight edge again or something, right down there at the bottom, whatever number that crosses with, that's the percent you're putting on the line on the bottom of the page. So for me, it's about 35, which is what I guessed. Maybe about 36 or something. So where that crosses with your x-axis at the bottom of the page, that's about what number to put on the bottom. And then you have 4 questions to answer on the back, and those questions need to be in complete sentences. You have to restate the questions in your answer, and you have time to get several of them done. You have a few minutes. So number 1 says explain any weight changes that were noted during this experiment. So you need to write out all the weight changes that you saw in the eggs. I mean, it doesn't have to be like, oh, 0 was this, 10 was this. You can say, the beakers between 0 and 30% were like positive weight changes, and 40% to 60% were negative weight changes. You can say that. And the rest of them, right, like I said, use complete sentences, restate the answers. If it's asking about which beakers, then you need to say which percent beakers. And those percentages are listed in table 2.1 in the first column for you to refer to. Alright, so I just explained this slide. I'm going to move on to the slide. So here I've got some information about osmosis and how water moves in and out based on the concentration of sugar. It wants to kind of get the amount of sugar and water equal both inside and outside the egg. So depending on how much sugar is outside the egg, the water might move outside or inside to equal them out. So I've got some examples of weight loss and gain over on the side, over here, and then talk about equilibrium here. Hopefully this will help answer the last page.